In 1959, Richard Feynman, in his American Physical Society lecture, Plenty of Room at the Bottom, challenged physicists to build microtechnology. Today, more than a half century later, we are at a nanometer scale. Here, in the 21st century, it is time for a new and better challenge, the ultimate nanotechnology challenge, building identical snowflakes.
It is said that no two snowflakes are identical. The Snowflake Challenge is to build a self-sufficient nanotechnology machine, Santum, that can produce multiple identical copies of a snowflake template. Water molecules are at a 1 nanometer scale. Ideally, the Santum should be able to draw water out of the air, chill each molecule, and place it into a structure that can be replicated with a high precision and accuracy. Santum can be used to build solar sails using carbon for interplanetary and interstellar exploration.
Solar sails use photons to move about. Although photons are massless, they carry both energy and momentum. The source of the photons, or light, could either be a star or lasers, as in the case of the proposed breakthrough Starshot project. The most effective type of solar sail is very lightweight per meter squared and also has a reflective surface, which would provide twice the change in momentum of the photon bouncing off the surface compared to mere absorption. And you also want reflection because you want to keep the temperature of the solar sail as low as possible as well. There have been several successful tests of solar sail technology in low Earth orbit. These systems have been bulky and quite heavy. They use mylar films that are micrometers in thickness. Ideally, we would like to have a thin film comparable to the wavelength of the light, which would be several hundred nanometers. Materials like graphene are a possible choice for the structure, but as we know, graphene is transparent to light, and so we have to consider composite structures, layered structures, laminar structures. The first solar sails set into orbit are to this technology what the Model T was to the automobile. We have to think of evolving technologies with composite materials that will be lightweight and at the same time fulfill the needs of a solar sail. The breakthrough Starshot project proposes to send small spacecraft powered by solar sails from our solar system to the closest star to our sun, Proxima Centauri. It would take about 20 years to get there. A more interesting destination for an interstellar project would be Tau Ceti and Epsilon Eridani. Proxima Centauri is a M-dwarf or red dwarf star with a few exoplanets, but it appears Tau Ceti and Epsilon Eridani are both evolved star systems with stars similar to our sun. In the Tau Ceti and Epsilon Eridani systems, there appear to be several Earth-like planets, and it appears at least one or two of these Earth-like planets are in the habitable zone. Both of those star systems, however, differ in one way. One is a lot older than the other. One is 5 billion years old, comparable to the age of our solar system, and the other one is only 800 million years old. So If we're prepared to wait a bit longer and use a higher efficiency solar sail, perhaps those two stellar systems would be a better destination for an interstellar project.
The top system is Tau Ceti and the bottom our solar system. Tau Ceti has 2 super-Earths within its habitable zone.
Graphene would be a good structural material to use in these solar sails, but as I've mentioned already, graphene is transparent to light. And so you have to build composite structures. Graphene you can manufacture into different shapes, so as a structural base is probably very useful. But you would have to build up a layered structure, and a possibility is to build fractal antennas above the graphene, and by making the structure smaller and smaller in scale, you might end up reaching an optimum point where you can impedance match the surface structure with the incoming photons to produce a high efficiency sail. This is what you see in these successive patterns, which are simple fractals taken to smaller and smaller scales, until at some point the wire, which could be made out of gold, for instance, gives you a high efficiency sail.
We have begun to land and assay asteroids for mineral resources. Solar sails can be used to transfer asteroids into the near-Earth circular orbits around the Sun. Santum can perhaps use the carbon from the asteroids to make the solar sails.